let's look at what are the potential for what's the potential for the cloud in the future. I'm going to go over a few topics, and I'm not going to just talk about cloud, because cloud is all part of computation, software development, all sorts of different things, infrastructure, hardware, you name it, and social impact. And so what I want to do is I want to talk about all of those, looking at cloud as the focus, but looking at where the cloud might go in the future. So one of the things that obviously has to be discussed is, will cloud be the dominant paradigm for computation in the near future? Is this the way a lot of computation is going to go? Software development, apps, all that sort of thing. Are we going that way? So in a way, we're going back to what computing started out with, which was a centralized model. So in the 60s and early 70s, what you had was a mainframe, and that was one central computer, and everybody connected to that. Now, the thing is, that's actually where we got virtualization from. That's where we got modern operating systems from. We got all of those different things that we need for cloud back from the time where people were working on mainframes. But we started from mainframes, and then we went much more distributed, where you had smaller computers, mini computers, personal computers, servers, small servers, and everything started to become distributed. And particularly when we went to mobile, where now part of what you're doing is distributed in something that is a handset, or is something like a watch, or or something that you're carrying around. And now we're even going to the idea of objects being smart, in that they're sending back data. So we have sensors that send back data, and then maybe there's an actuator that's also out there controlling some piece of hardware, and it's talking to a cloud system. So are we in a way going back to the idea that even though the infrastructure for cloud is very distributed and is based on the notion of client server, is it that we're going back to this idea of going to a virtual center where everything's being controlled from there? And some of this is being driven by economics. There's no upfront infrastructure costs. What happened was that modern industries that were running totally on computer-based programming, either controlling their economic structure, their financial structure, or in fact was their application, they found that there was a lot of infrastructure costs. So it wasn't just the fact that you had a computer. You had all sorts of things that went around computers, and those are very costly, and they're prone to breakdown. So not only do you have to worry about a computer system breaking down, you have to worry about everything else breaking down as well. Just this week on campus, the chilled water went out, and all of a sudden there was a problem, because that feeds the air conditioning systems. The server rooms on campus need the air conditioning. It just so happened that the cold water backup failed. And so you had all sorts of buildings starting to go offline on campus. So it took them a while to figure out how to get it back up. But part of the problem was that they had to not fix the computers or even the network. What they had to fix was the backup chilled water system. So you have those types of things that you have to be aware of when you're actually designing a computing infrastructure. And so because of this, the pay-as-you-go or the pay-as-you-use model is very attractive for a lot of different applications, for a lot of different industries, because you only pay for what you use. This also comes about when you have something that's very bursty. So you only have huge number of requests or a lot of computation going on at certain times, and at other times you have very little. So paying for that huge infrastructure, that huge computational structure to only be using it for part of your time is very costly. And so people were driven by the attraction of pay as you go. Obviously, this isn't for every application. If you have constant usage, then you don't get that much out of pay as you go. And in fact, you might actually get less because you really want to sort of pay up front, because then you usually get discounts. The other thing is that hardware keeps changing. And although you could say that the increase in speed and the shrinkage of size for integrated circuits is slowing down because we're starting to reach physical limits, you do have new hardware in that you have new structure. So you have GPUs, you have all sorts of other kind of specialty hardware that's being developed. And this is coming online with great frequency. And so you have the problem that if you're trying to catch up with this, or you're trying to keep up with this, there's a fair cost involved. And so you may be looking at hardware now that's only going to be bleeding edge for another year or two. And so are you going to every year, every 2 years be totally recycling through all of your equipment? That's probably not economically feasible for too many industries. And so you have the problem that if you really want to keep up with the new systems that are coming in, the new hardware that's coming in, you probably have to have somebody else that's footing the upfront infrastructure costs. One of the things that started the cloud and is still very much a dominant part of the cloud is data. And so the very first applications, as we saw, were storage applications for things like Dropbox or Netflix or things like that. But we're starting at the file storage. That was a big thing, and it still is a big thing. Everybody backs up their data to the cloud. Almost everybody's laptop is backing up to the cloud. Almost everybody uses something like Google Docs or Dropbox or some variant of that to do group work, to share documents, to do work on documents at the same time. All of that is dependent on the cloud. And now what we have is that we have even more streaming data coming in. So not only do we have files, now we have constantly streaming data. So it has predominated in media. So you have the Netflix or the Apple Music or Spotify or whatever you want, spewing out all of this video and audio, so media that people want to consume. But you also now have into the mix IoT or Internet of Things. So now you have all sorts of devices like thermostats, refrigerators, any appliance, anything out there, locks on your doors, everything like this. This is all now streaming data, probably not as much as you would have coming from maybe Netflix, but it's starting to become huge, and particularly more as we put it into cars. It's already there, but now like connecting cars almost continually to a network, connecting all sorts of things in the city, all the infrastructure in the city being monitored that way, traffic being monitored that way, power being monitored that way, all of that, and making that available too for people to, like industries or developers, to go in and be able to get that data, to be able to manipulate it and work with it. You have a lot of data being streamed around. And so cloud is going to be central to that for a long time. You can buy all of that storage yourself, and then obviously it's gotten cheaper and cheaper. You can get little tiny devices now that have a terabyte, which used to be like a phenomenal amount of storage. Now a terabyte's nothing. You put that in your pocket. But the thing is that still costs in maintenance and keeping it up to date. And if we're talking about hardware going out of date, media, for like the medium that you're storing information, that keeps changing, and that's been changing incredibly fast over the last couple of decades, so that now something stored 10 years ago, can you even read it anymore? So you have all this problem that not only do you have to have the ever-increasing space because you're producing more and more data, you may have to be recopying all the data and refreshing it from what you had before. So this makes us think about, how do we design software? How do we actually adapt our development strategies and our development pipelines to this fact that you have really the cloud dominating data storage? And so with this, you also can apply it to software design and development, that a lot of that is going totally into the cloud. You have the GitHubs, the GitLabs, all of these different Docker hub, everything like that. You have all these things that are there in the cloud for you to put your information in, connect your team to that, have group development, have pipelines going through for development and testing and deployment. We have to think about more and more is going there, because more and more is being provided. We look at platforms as a service or software as a service. They're providing you with all of these tools that before might have been maybe too expensive, too costly, or too complex for you to run in your own shop. But along with all of this, you have these new security considerations, because now everything's going to the cloud. So you have to be pretty confident that it's secure there, particularly if you're developing commercial applications or you're storing sensitive data. You don't want those things getting away from your control. It also means that we have to rethink how we train and deploy system administration. And so the model a few years ago was basically a system administrator. They set up all they set up the computers, they set up the operating system, they did the updates, they did backups, they watched as things, happen. They took care of security, so they were monitoring, they were logging, they were looking through the logs, they were doing all that. Well, now you have two types of system administrators. You have the upstream and the downstream. So upstream, that would be what the public cloud provides. So they have lots of people that administer all of the computing systems that make up their cloud platforms. So you have those people doing that kind of system administration. And then you have the downstream one, which is done by the user. So, or there's the users, system administrators. And so now you have two sets, and they are different. Because they're looking at different things. They may have different backgrounds, different amounts of training, and you've got the upstream ones have to be very high level, well-trained system administrators that know the public cloud system inside and out. But in downstream, you need people who are very flexible to actually be able to survey the landscape, to know what kind of infrastructure, what kind of platforms should be integrated into the systems, because they're more integrators, and they have to take all of this as data, information management from the upstream people, and they have to make sure that they can manage it for their users. Because as we saw when we looked at security, a lot of the security flaws are in fact from the fact that the provider can't stop you from doing certain things. If you want to open up your data to the world, they can't really stop you from doing that, because they have to let you open it up for some people. And they couldn't possibly manage checking and then trying to second guess you. And people wouldn't like that. If I want my stuff open, I want it open. But that is where the system amendment comes in. And so you still have system administration, but how is that going to be, what's it going to look like in the future at the downstream end? It's not going to be the same as it's going to be at the upstream. And this comes into the future of workplace, because, and we're seeing it now. Actually, this is probably the best time to talk about this, because we're all going through this dislocation from our workplace. And so this is only going to be more pronounced after the pandemic, because of what happened in the pandemic. But there's all different things in the future that you're going to have to look at. So data centers, which ones do you use, public or the private? Who will have them? What will they look like? Do you want to get into data centers? Do you want to totally give up that sphere to the public data centers, such as the public cloud platforms? Will there be private ones that, because there's some specialty ones where, like for IoT, you can go to IoT clouds, you can do those sorts of things. So now you have to choose between all of the different types of data centers. Or do you actually want to do some on-premise stuff yourself? And then things like desktops, workstations, do we need them anymore? People like their laptop because they can pick it up and take it anywhere with them. And so the sort of the portability of the laptop sort of ensures that it's your big phone kind of thing. But the desktop, where is it going? Because you have the notion that a lot of things that the desktop was doing, you can now get as software as a service or platforms as a service in the cloud. So do you really need anything besides a laptop and maybe a big monitor? So maybe we're going away from the notion of desktops or workstations. Workstations were there particularly also because they usually had specialty hardware or accessories onto it. You might not need that as much anymore when that horsepower that you needed or that specialty hardware that you needed is in the cloud. And so all you're really doing is you're providing the GUI to it with your laptop. And so will we really need that type of computer? And you can see that that's coming in, if you follow the last update to Apple's hardware, with the Mac books and all of that, they're going to having the same processor basically as what they're putting in their phones. And so they're going to have this continuous hardware, like personal hardware line. And then if you want anything really fancy, maybe you just go to the cloud. That also puts us into this notion, do we actually buy software anymore? Now, that's kind of, in a way, we're different from a lot of people because if we want to buy it, we can buy it, we can also steal it or procure it, or we know about all the open source versions of it. And so we're not the sort of the general public, but now even for the general public or general business public, why not rent software? Why do you have to own it? In fact, there's little reason in a way to own software because it's constantly changing. One of the things that people would object to in having everything rented in the world is that they like their devices or they like their objects. And they're not changing. They like them as they are. But the whole point behind software is generally that you want it to keep getting better. Maybe you don't want the interface changing, but you do want the software getting more efficient, doing more things, being cheaper, being faster, all of that. And so why buy when you can rent? And with rent, you only pay for when you're using it. And maybe you only pay based on how much you use of it. And so there's lots of reasons to look at the future of software being totally away from the purchase model and totally into the rental model, or something that's a platform that you already get when you go onto a certain system. Updating software. If we go to renting, if we go to a cloud model, then the strategies for security and versioning and development of these of software starts to change, because now you can do a little bit more if the software is residing in the cloud. You have more professional management. That means updating is done all the time. One of the big problems in general security for computers is that while most operating systems are constantly patched as they find security flaws, yes, in theory they're patched, somewhere they're patched, you can get the patched version, but do people, and in fact that's why you see most of the attacks on computers aren't on the bleeding edge version of the software where you think, okay, that's where the holes are and that's where the security flaws are because we haven't found them yet. No, they're on the older software where we know all the flaws and people haven't updated their systems. So if we go to things being much more based in the cloud, you're saying that they're much more based in a professional system administration environment where now we have everything being updated, new versions being put in, everything like that. But that means we may have to change some of our strategies for development. And we looked at that with containers. Containers now are the way that people are looking at distributing software, at keeping track of versions, of handling the problems of versioning multiple libraries. It's now being funneled through the idea of containers. So we have the cloud and a lot of things revolving around the cloud, changing the way software is going to be developed. Now, that's not to be said that the only place you see containers is in the cloud. None of that. I mean, the cloud doesn't really have anything very special, but it amplifies some of these trends because it just works so much better in the cloud. Or in fact, the cloud works so much better because of these, the paradigm shift that we're going through with software. So now we have the whole problem of we're getting more and more choices out there. Choice is always a problem because you have to actually do something and you have to know why you're doing it. So there's, as you know, like right now we have multiple public clouds. How easy is it to go even between it? So you have some experience in this, and that you probably experienced 2, maybe 3 different types of cloud systems when you're doing your assignments. The thing is that there's differences. And they don't have to be profound differences, just differences in way you name things, call things, interact with things, the APIs, the CLIs, all of those things are different. And they're close enough to be annoyingly, almost standard. And so the issue we have is that we have multiple clouds out there. Will we ever get to the time where we can have full interoperability amongst all the public clouds? So maybe you can have your storage on AWS and some of your compute in Azure and some of your system management on Google. If you want, like sort of best of breed, you pick the best one, but you don't care which platform it's on. Are we there? Who knows? Like that. We aren't there. We know that we're not there. But will we ever get there? This is the age-old problem in computing: is can we come up with some common standards everybody agrees to, or at least most people agree to, and we write to that. That's like it's not easy, and that will determine how interoperable we can be. And now remember, also the public clouds don't have any incentive to make themselves more interoperable because they really want to lock you in, right? They want vendor lock-in because they don't want, if they're AWS, they don't want you to go to Azure. If they're Azure, they don't want you to Google. Google doesn't want you to go anywhere else. So you have all these problems. And there's always new players coming up. So what are you going to do if a new player comes up? They're amazingly cheaper. It doesn't matter to a certain extent if they're not following the standards. People might move just for the price point. And then we have, if we move out of the world of public clouds, we now have the public-private issue, or the hybrid where you're going to have them all mixed up together. Some of this comes down to privacy and security. So what do you have to put in a private cloud or a private data center or on-premise servers or whatever? Because you have to consider, once again, interoperability. How easy is it going to be able to do this? But if you're going to break it up and put some in public, some in private, how do you break it up? All right, so you have to look at all of those different factors and figure out what can you do and what should you do? Because a lot of people would say, oh, it's much more secure if you're not in the cloud. It'll be more secure in our own private data center. Well, some of the biggest break-ins have been in private data centers, have been in on-premise server farms. It's the jury's out about which one is actually more secure, but there's been huge failures of security on both sides. And in fact, it makes sense, depending if you are a small to medium-sized shop, that you probably won't be as secure because you just don't have the person power to actually ensure security. You may not have the people to do all the monitoring. You may not have the people with the right expertise. And yet these people have to be constantly retrained as the newest and newest things come out in security or in what you're using in the cloud or on your on-premise server. So with all of that, you have problems about where do you put yourself vis-a-vis privacy and security, and whether you put some in your own shop and some in the cloud. And when we look at the future of data centers and hardware, who will control these various areas? Vendors obviously want to lock you in. That's their business model. They don't want you doing hybrids. Really, they don't want you worrying about standards so you can interact with another system necessarily. They'll all do that. They'll all try to give you some of that. But the thing is, it's not their priority because they really would like to say staying within our universe. I mean, obviously it's a better business model, but it's also easier when it technically because there's not as many moving parts and you control all the moving parts. This is the difference between, let's say, the Apple view of the world, where you control everything from hardware to software. So they look at their phones or their laptops as being something they can totally control. Whereas you have the other model, the Android model, or maybe you could call it the Google model, but that's where you have less control over what people do. But then you have all sorts of issues with that, in that you have the fact that you have to maintain huge hardware bases because anybody can put, let's say Android on any kind of phone, and you can't necessarily optimize or make very efficient some of the software because it has to be applicable over so much hardware. So you have all sorts of issues on both sides. And so if you're only a software shop, that's different than when you're a hardware and software shop. So the difference between Microsoft and the difference in Apple is hardware, whereas Microsoft was software. Different business models, different outlooks, and different when you come to the notion of what cloud is. Now, one of the new areas of cloud is edge computing. And we touched a bit on this in the course, and that was part of the assignments. With edge computing, this is the idea that you want to put cloud-like services geographically close to either the user or the data. And so this is the idea that we have the computing centers. There's only so many big data centers that even AWS has. So if you look on the map that AWS has, you see there's a lot of them, but they're still not everywhere. But the users and the data are everywhere. So with the edge, we're looking at edge computing, we're looking at something that's totally distributed. It's not a centralized model. And once again, I want to come back to this, that the model that cloud computing is going on is a centralized one where you have this virtual center to everything, but its infrastructure is actually very distributed. It's just that the idea is that you can conceptually think of it as this center core of stuff that everybody gets from. But the problem is that that's not very efficient. It's not fast. And so performance drives a lot of things. And the nearer you are to the client, the faster the service. It just makes sense. If you're halfway around the world, you are going to be slower. I don't care whether you have 5G or not, you're going to be slower than if you're next door. And so the idea with edge computing is, can you be next door to everybody? So the idea is that these edge computing nodes are sort of like tentacles reaching out from the cloud, and they're going to be close to the action. So they're there to give you all of that fast contact with your user base, or to grab all of your data. So why is this important? Well, obviously a lot of cloud computing is based on networking. If you're not connected to the internet, you're not doing cloud. And so one of the problems is that in networking and any sort of communications, the last mile is really what kills you. So that has to be fast enough to give you good service. That's what actually determines good service. So you can have the fastest backbone network imaginable, but if that only goes to the sidewalk, and what goes from the sidewalk to your house is really slow, you're still going to have slow service. So all of the system is as fast as its slowest parts. And so edge is the idea of, let's make those last miles fast. Let's make them let's take that slow part out. So when you have things like autonomous cars or wired cities or anything like that, some of those applications need to be almost real time. With cars, they're going to have to be real time if we ever get truly autonomous vehicles. But the problem there is that you can't have lag, right? It can't be like, when we're doing lectures from, on the internet, and it's like, okay, if you have a little bit of a glitch, or the, subtitles go away, or, my voice cuts in and out a little bit, nobody dies. And probably you can sort of fill in if you have a little bit of static or a little bit of lag. It's annoying, but it's not that dangerous. But it is for applications that are controlling things like autonomous cars or power plants or anything like that. It's dangerous. I was just reading an article this morning where the US Navy was investigating some accidents where various ships had hit other ships. And what they are actually ending up doing, this is for a slightly different reason, but it's related, in that they're getting rid of all of the interfaces to the steering system for the ship. They're getting rid of all the touch screens because they said far too complex, didn't work. They're going back to the old-fashioned analog type systems. They want like a stick to move around. They want to have, like pull it and stop the ship. The thing is that it's not the same sort of thing, but it's related. The idea that what you need is a lot of control, and we can't have any lag, and it's not a video game. People really do die if you have lag. It's not like, oh yeah, okay, your spaceship in the video game, got shot up. This is important. So with edge data centers, they're supposed to be small, agile, and they don't have as many needs. So the idea is you can make a lot of them, and you can put them close. You can put them all over in places where you don't have the big data centers. And maybe that's because they're not near big populations, or maybe there is not as much power in that area, or not as much connectivity, whatever. You don't need as much when they're tiny. In fact, they're thinking with a lot of edge data centers that they have now, they can fit into a container, a shipping container. And they just take that container and they put sometimes they just put a satellite dish, or plug in a cable if they can, and plug in some power, and there it is, right? Like that, done, right? So the idea is that because we're starting to get faster and faster things out at the edge, like 5G, that some of the structure for edge is becoming more and more possible. And so you can have short turnaround time. So if you're looking at doing things with autonomous cars, you put it beside the highway, and maybe you can handle it from there. If you want to get some of this data collection power and computation power up to the far north, maybe you can drop in these little things all over the place, so that you can actually get out to people that don't have, don't really benefit from these big centralized data centers. So the idea here also, too, even with a big centralized center, they can start parceling out things to the edge. And so maybe your users are all over the world. And so, like you want to get it as close as possible to them. And so it can serve out your stuff at certain times of the day, when it's day in there in certain areas, out to the edge. And so this is one of the areas, exciting areas that's coming out. So let's look at the future of data. It was the first app. And and it's continual. It's not just the newest. It's always going to be the newest because we're always going to do things with data. So the only thing that's really stopping data from going into the cloud is security and good data practices. Figuring out how to do it. We have all sorts of data that's going into the cloud. First, it started out with traditional sort of file storage. Then we went to data streams. Now we're looking at different types of data streams like IoT data, and we're just looking at massive amounts. And who knows what the next greatest thing is going to be in collecting all this. Maybe a lot of it's going to be not just coming in from IoT, but IoT specific to human beings. So medical apps that are going to be constantly attuned to what's happening in your body and making sure that you're going to be okay. So we've got all sorts of solutions out there. We started with traditional databases. They've got blobs. They've got all sorts of things. But the real question is capacity. And it comes down to, will we store everything? Are we trying to store everything? And is that actually the wrong thing? Are we looking at storing too much? Can we actually even manage this? Are we doing this just because we can? And this is a problem in that you get all sorts of applications now that are taking in all sorts of data and storing it and doing all sorts of things with it. But it's like, are we doing it because we really have a good idea of what we want to do with this data? Or are we just collecting it because maybe we'll find a way to get some value from it at some time? Or like, do we really know what we want to use it for? Or just, are we hoarders? You know, like, should we have another type of show that, like when they have hoarders and they can go to people's houses? Well, maybe they should go in all our storage devices or data centers to see what are we hoarding out there. And this is a big issue, part because obviously there are capacity, physical barriers to storing everything. But the other thing too is that if we do, are there going to be bad downstream consequences for having all of this data? And we're seeing this discussion right now with all of the data that we're collecting from social networks, from IoT, from all sorts of things, that people are starting to say, wait a minute, stop. This is not right. We have to figure out what we really want to do with it, and we have to do it in an ethical manner. So if we look at all these things, what's the future of computing? Not just cloud, but what's the future out there for computing? Well, obviously we've been going towards the idea of having bigger, faster computers for a long time. So big clusters, big iron, applications that scale, auto scale to doing everything they need to do, so that we get this sort of, what we're trying to go is seamless quality of service, those sorts of things. And a lot of that has come down to things like the idea behind containers. So containers are neat because you're virtualizing just what you need for a program, but that actually gives you all sorts of side benefits. Like, people use containers for privacy. So you could have data that people can't actually see because it resides in a container that you can't look into, but the container can answer questions about it. And so it's a way to, a lot of publishers do this when they have copyrighted information that they want to give you some access to, but just not all of it, right? So you could ask the container some questions about the copyrighted data and get out just enough that it adheres to fair use. So you have those sorts of things that you can do with containers. So containers have lots of nice upsides with regards to infrastructure and computational efficiency and all sorts of things like that, and versioning, and having everything look the same on different platforms. But there's also all sorts of exciting applications that you can use containers for that push what you can do with this technology. Then we also have this notion of going to serverless, or basically small microservices, stateless services that can do a lot of different things and really moves us away from monolithic software design. And so it basically is taking what we always teach anyways, which is you should go modular, you should make it as small as possible. But now this is doing it to an extreme. And the fact is there's lots of things that can be done in a stateless manner. And there's lots of things out there that do that or have limited state. And so we can do a lot of things that we used to do before with like a whole virtual machine into just these serverless functions, or maybe a serverless function that contains a container or something like that. So now we have a different paradigm of how we want to design software, what in fact we do want to design. And so with all of this, we also are inventing new ideas about versioning, because versioning has always been an issue. We always want to improve things, but that leads us into trouble because sometimes you can't get to the new one, or you need something from an old one. And we have all this, and sometimes you don't even know which one you're at, which version you're at. With things like containers and services that manage containers like Kubernetes, you can set up a whole new versioning paradigm. And this is going to be very influential because this means that you can upgrade things in a nice, seamless way that are much more efficient and safer to do. So I've noticed recently that every time my laptop or my desktop updates itself, it always comes up in a really terrible mode. And part of this is because this is the old-fashioned, monolithic operating system design instead of the upgrading of smaller, very much more contained things like containers. And so software design and development paradigms are going to have to constantly keep adapting to what we can get at the edge, what we can do with microservices and like very small microservices like functions. All of these things will not just drive what's being done, but what we can think of doing. And so we're going to rethink how some things are parceled out. One of the things, if you look at I think of it as an example of a word processor, as being a great piece of big monolithic design where there's lots of parts of the system that you never use, right? Lots of fonts you never use, lots of different structures you never use, all those things, but you have to have them. And so you get these big monolithic pieces of software that have been known for having Easter eggs in them, have been hacked, all sorts of things like that, and are big. So when you're moving them around, they're big. Wouldn't it be nice if you could just say what you wanted and then add other things on when you needed them? And so you can have the small little core things and just add other containers onto them to work together. Wouldn't that be wonderful? Then you don't have to buy the whole thing or rent the whole thing. You just rent what you want. And we can do that. We're starting to get that so that we can design for that now and actually instantiate it through something like the cloud. And this leads us to the whole idea about networking. Everything in cloud is driven by networks. But then again, almost everything now in computing is driven by networks. You've got issues of scaling, edge computing, very, very fast networks, geographically distributed cloud resources. We saw that geographic distribution of data centers, cloud resources is the way to go if we want to have stability to guard against natural disasters, human-made disasters, all sorts of things where we can move things seamlessly and very quickly to other data centers that aren't affected, so that you don't even see that you had like a major power outage in one area because everything can be moved quickly to another area. So you have all of this, and same with, then with backups, when something is destroyed in one area, you have the backups in another, and it can come up immediately in that other area. That is driven by networking because everything has to be interconnected. And the speed of the networking determines what you can design. There were a lot of ideas over the past 40, 50 years that people had that were really good, but they weren't doable because the network wasn't fast enough. And as soon as the networks became fast enough, it's just the same as when the computing chips became fast enough, you started to be able to do things that people had thought of for decades. It wasn't like that the idea was new, but you couldn't do it because you didn't have the speed. And so now we're seeing the same thing, but with the network. And we are all experiencing this right now because we're all trying to work from home. We're all doing everything. We're doing our social lives, our professional lives, our educational lives. Everything is on the network. And we're seeing that the network is getting saturated. The network isn't standing up as well as it could. Obviously, it's doing a fairly good job, but you see things where we get dips in performances, we get lags, we have people dropping out. And, you know, obviously this is dependent on where you are in the world, but we have this problem that there are some things that we're not going to be able to do unless we have fast networking. And the thing is, the more and more we depend on the network, the more we're at ransom to the network. If the network's not fast enough, the network's not there, how are we doing things? And so we have to look at how are we all responding to this, you know, this pandemic where we have to stay away from each other. And so now our contact is virtually all just networking. I mean, think of this happening if you didn't have the internet, right? What would we do, right? What would we be looking at with not Netflix? How would we be doing education? What would we be doing? It's a lot harder and it's a lot different, right? So the thing is that we have this world where we can decide how we want to design based on what kind of networking we want to design. And so in a way, what you're doing is designing the networking first, getting that done, and then designing out from that, because that gives you possibilities. And in fact, what you do is just look around, because there's lots of ideas that were out there. They just couldn't be done because they didn't have the speed or the interconnection. And we still have this problem. We aren't interconnected everywhere. If you live in Northern Ontario or Northern Canada or in maybe the Amazon or parts of Africa, are you connected as well as you could be? In some places more than you would think, because actually phone networks are much better in Africa than even here sometimes. But the idea is not everybody is connected. And so if you are in, let's say, Northern Canada, and you want to set up a company, an industry that's based on having internet connectivity, you're screwed because you don't. And the connectivity you have is expensive, it's patchy, and even when you have it, it's not fast. And so we have to think about this. How do we do this? Is it through things like Edge? Do we put our money into that? Do we put our money into satellite, low orbit satellite network? How do we make sure that everybody has access to a level playing field? Because now networking determines economic and social, to a certain extent, equality, or at least a basis for equality, because then you have access to things. So you have to think of this. This is actually very, like, this area is very important socially and ethically, because the what we do here will actually determine a lot of things about a lot of people's lives. So this isn't just like, oh, I can play video games faster. This is, there can be economic development for people who never had it before, because they can do it where they are. They can choose to live where they are and still do this stuff because they're interconnected at the same speed we are. So these things are important social issues that we have to think. Network-driven computing is really network-driven society. How do we handle that? And where are the important points for that? Another thing to do with ethics is really in the future of some types of software. And, you know, right now we have a lot of, what's the word for it? I'd call it propaganda about artificial intelligence and what it's going to do for everybody. I would argue that the network is actually more important to the world than AI, but if, you know, like, let's look at what are the issues when we look at the future of what kind of software we're going to produce. So what's going to be the new Office suite? You know, like we had before, Microsoft defined the Office by defining the software that went into Office. So we have, you know, word processors and spreadsheets that are that we have to put up with now for till the end of time, it seems. But what's the next level? What are we gonna, everybody's got that now. There's no, you know, like, not too much to think about there, but what's the next one? Bots and assistants. We have some of those now. They're still evolving, you know, no pun intended. We have maybe some things with machine learning that we can do in recognizing people or language or anything like that. We do huge data analysis, but there's all issues around these things. So while very few people debate, you know, maybe word processing spreadsheets. Well, I debate spreadsheets because they have made everybody intellectually lazy, but because everybody thinks they're databases. But even with all of that, they're not too challenging as to think, well, you know, like society's being ruined because of word processors. I guess you can make that argument, but probably not too successfully. But you could make the argument that there's all sorts of problems with some of the impacts that some of these other things like bots and machine learning and data analysis and NLP will do if not properly implemented, tested, and deployed. So we have a big problem with this because, and a lot of this is being sold on the cloud as a commodity. Not just on the cloud, but a lot is being sold in the cloud. So when we look at, let's say, IoT, we have this problem. Can we have too much, right? So, you know, like, do we really have to analyze the kitty litter every time the kitty goes to the litter box? I have my cat lying right here, and she says, no, invasion of privacy. So, you know, with all sorts of information, can we get too much? So we're going to have billions and billions of tiny devices out there. They're going to be polluting everything. They're going to be taking all this data. Some of it is going to be privately held. Some of it will be publicly held. How much do we want to give up of privacy and maybe security to get various benefits? To get, you know, physical security, health, more money, all that. Will we allow ourselves to be monitored and surveilled? And this is not something that's going to happen next year. This is happening now. So we've all made decisions about security and privacy with the pandemic, and lots of people have made that around the world with regards to their government. So what they get from their government, or the government wants to take from them. And there's lots of potential. If we hook up all sorts of thermostats and energy production and everything like that, we may be able to be more efficient in energy usage. And maybe that means that we don't need any more coal-fired generators. Maybe we don't need that next nuclear generator. There's, you know, like, maybe we can just use solar, wind, or thermal, or whatever, geothermal, whatever. It means that maybe with all of that, we can coordinate things, because some of those things now are being done very individually, right? But you might have to give up some of your control. Maybe your house thermostat is going to be controlled by somebody. Who knows? If we put sensors on infrastructure, public infrastructure, that could give us great efficiency. It could find out where pipes are leaking. It could lead to all sorts of savings. It could find out if infrastructure is crumbling. It could do all sorts of neat things. And really another sort of frontier that is rapidly being looked at, and devices designed and data being collected about, is health monitoring. You know, sensors that you wear, like a watch or a Fitbit or whatever, that are looking for various things. These are getting more and more sophisticated. You can put them in clothing. There's clothing for, maybe you want to track somebody that's got dementia, but you don't want them to feel, terrible because they're wearing like a dog collar or something that looks like a GPS tracker is on them. Maybe you want it in their clothing so that they don't even know they're being tracked. Now that also leads to maybe you're tracking people when they don't know, and is that good? It's maybe good when the person has dementia and you want to protect them, but maybe it's not good when it's your teenager that you're trying to find out whether they're going out and doing something you don't want them to do. So what, and with health monitoring, what is it? How invasive will people allow it to be? And who looks at that? And how do you give up that information? And who pays for this? So there is, in the US, some insurance companies are giving companies breaks on health insurance for their employees if their employees wear Fitbits, right? So now you have this whole thing of being, big surveillance. Is it good? Is it bad? We have to think about that. We have to decide what is good and what is bad. And when we look at what's good and what's bad, where does cloud computing sit with regards to climate change? Right? So if we look at it, we can look at like two sides. So if we have large data centers with thousands upon thousands of servers, processors, disk drives, all that, they have a huge ecological footprint. People have done calculations about how much it costs every time you do certain computations in the cloud or anywhere, but in the cloud, they've looked at it. And so you've got this fact that these are big centers. They take a lot of air conditioning. They take a lot of power. They're not small. They have a large ecological footprint. But then you could say, well, the upside of this is that they're usually controlled by organizations that have enough money to invest in bleeding edge hardware and infrastructure. So maybe the hardware doesn't produce as much heat as it did before. They can change everything there. You might not be able to re-kit your data center very quickly to have the latest chips that don't produce much heat, but maybe Amazon can. And the same with power consumption. There's all sorts of different things that they can deploy sooner than smaller centers, which might be using hardware that's 5, 6, 7 years old and is using far more power and producing far more heat than modern systems would. There's also the thing that edge computing might be the way to get out from, like you don't have to produce as many large data centers because you're going to produce all these little tiny ones that have much smaller footprints and actually can be adapted to the power and networking that's in the area. So in other words, they can be far more personalized so that maybe they can take advantages of some place that has geothermal or it has good satellite connections or something, because they're small and they can be deployed faster and much more easily than a big data center. Maybe edge computing will help with ecological impact. And then a last thing to think about is, and this is hard to decide, they have all those big AI and machine learning modules on the cloud platforms. And some of them are pre-trained. So you just like hook onto them and throw your information at them and it gives you answers or whatever. It analyzes your image, does all sorts of things, but they trained it. And so with AI or machine learning or whatever you want to call it, most of those methods actually don't cost a lot to use once you've trained the system or once you've built the system. But building or training the system is really expensive computationally. And they have all the big hardware to let you do that. But I really should look this up. I saw the figures for what it costs every time a class runs, like these traditional AI exercises where everybody trains the same network or, everybody's building deep learning networks. A lot of that is wasting a lot of energy, and it has a huge ecological impact. There's a big footprint from doing that sort of work, because right now we don't have AI or ML training or computation that isn't super expensive with regards to how much computation you have to do. These things can train for a heck of a long time. And so what's really good about that is with the cloud platforms, you're charging you huge amounts of money for this. So this is good actually, because maybe we want to discourage people from retraining the same thing over and over again, and usually poorly. And maybe we want to enshrine the very well-trained, well-refined, tuned models for doing various things like, say, image analysis or facial recognition. Maybe we want to do that in one central place where it's really, really well done, and then have everybody like throw their data at it, but only retrain when absolutely necessary. Now we're nowhere near that, even while they try to say it, we're nowhere near that, because there's not the guarantees that their models are that good. And we're nowhere near the culmination of that research into those types of models. But maybe standardization and centralization will help this way. It won't help researchers. I mean, they're always going to do what they're going to do, but maybe it will help everybody else is just sort of on the periphery that needs that stuff, but it's too expensive for them to train. And nor should they, because they won't do it well, and they'll waste a lot of energy, generate a lot of heat doing it. So we have that possibility that maybe we can get that out through something like the cloud. So what I'd like to do is I'd like you to think about all of these things, because I want to talk about this on Wednesday. So I'm going to now, let me stop sharing and stop